Kia ora, Year 12. This is question 2C from last year's Algebra exam, and it's all about compound interest. The question seems to go on forever, but it's got 3 parts. So I'm going to have a look before we start at what it's all about. It's well worth reading through all 3 of the questions before you kick into doing the first part. Right, so Jessica is investigating a compounding investment, and that runs through the whole question. She wants to know how long it would take for an investment of $1,000 to double in value to $2,000. Right, so we've done lots of questions like that in class. Right, so we're going from $1,000 to $2,000. So she writes down this equation. And there we are. That's our pretty familiar looking, hopefully, compound interest equation. Right? We've got the 2,000, the final value here, the 1,000 that she's starting with in here. We've got 1 plus the interest rate, and we've got to the power of a number of years, d. So what we're trying to figure out here is if the investment takes 11 years to double in value, what is its rate of return, right? So d is the time that the investment would take to double in value in years. And so here we're going to say, well, what if d is 11? Oops, turn that off. So if d is 11, what must r be? That's what this first question is asking us, right? So r is the rate of return on the investment as a percentage. For example, if the interest rate is 8%, then we'll have r is equal to 8. Okay, the second part of the question asks us to rearrange this to make d the subject. So the question could have just said, make d the subject, but instead they've told us to show that it's this. So this actually tells us where we want to get to. And then the last part of the question is this. In her research, Jessica comes across a simple but approximate rule for calculating the time that the investment would take to double in value, and it's commonly called the rule of 72. And the rule of 72 says that the doubling time is 72 divided by r. For example, if we had an interest rate of 8, then the rule of 72 would tell us that the doubling time was 72 divided by 8, which is 9 years. So she wants to try and figure out how close that approximation is to the actual doubling time. So in the first part of the question, we worked out that this was the doubling time. Get rid of that, that's getting very messy. So this is the exact doubling time, right? This is the approximate doubling time. And she wants to know how close together they are. And the last part requires us to show that the r value for which this one will give us exactly the right answer solves this equation. Okay, in other words, when will the d from this one match exactly the d from this one? And that's your big clue about how to solve that problem. We're going to equate those 2 things. Okay, so if anyone is still out there watching, I'm now going to go through the 3 parts of the problem. So let's just clean all this up. With this question, I'd like you to pause the video here and just give it a go before you go through what I'm doing. Make sure that you've got pen and paper with you, because just watching this isn't going to do anything. Okay, so the first one, kind of the warm-up. If the investment takes 11 years to double in value, what is its rate of return? So let's work over here. We've got 2,000 is equal to 1,000 times 1 plus r, the interest rate that we're trying to find, and we're told that the doubling time is 11 years. Okay, so we have to solve this for r. We've done this hopefully lots of times. The first step is to divide 2,000 by 1,000. So we get 2 is equal to all of this to the power of 11. To undo the power of 11, we need to take both sides to the power of 1/11. Two to the power of 1/11 works out to be approximately 1.065041. So looking at that, what we've got here is that 0.065041 is equal to r over 100. So r is equal to 6.5, and that's to 1 dp. In other words, what were we asked for? What is its rate of return? Well, its rate of return is 6.5%. Okay, so there we go. That's the first bit done. Right, so I think the hardest thing with this question is just keeping track of what you're being asked to do. So the next part of the question is where we have to rearrange it and make D the subject. So let's look again. By making D the subject of the expression, we have to show that we can write D like this. Okay, 2,000 is equal to 1,000 times 1 plus all of that. The first step is divide by 2. To divide by 1,000 on both sides. So 2 is equal to this to the power of D. D, not some weird trapezium. The next step that we need to take is to take logs of both sides, because at the moment this D is up in the power and we don't want that. So let's log both sides. We get log 2 is equal to the log of this. And applying our log rules, the log of 2 is equal to D times the log of this. So, rearranging, we can get D is equal to log 2 over the log of 1 plus r over 100. And that's what we were required to do. So, as required. So there we go, right? We have to show that the doubling time is equal to that thing. So this is the exact doubling time, right? So here it is up here again. So now for the last part of the question. Jessica wants to compare the exact doubling time with the approximate doubling time using the rule of 72. So rule of 72, D equal to exact D means that we've got this. Well, the rule of 72 doubling time is 72 over R. And the exact doubling time we just worked out was equal to this. And we have to show that this is the solution to this equation here. Okay, so we're going to rearrange this, and we're looking to end up with 2 to the power of r, blah, blah, blah. You can see at the moment that we've got fractions on each side. So the first thing that I would do here, even if I didn't know where I was trying to go, would be to multiply both sides through by r. I'm going to go extremely slowly here. So 72 is equal to r log 2 over log of 1 plus r over 100. The next thing that I'm going to do is multiply both sides through by this denominator. That's going to give me 72 times the log of 1 plus r over 100 is equal to r log 2. We've already used in this exam question the log rule that when I have the log of a to the power of b, that equals b times the log of a. And now we're going to use it in reverse, right? So we're taking this 72 and we're going to flip it back into my log. So we have the log of 1 plus r over 100 to the power of 72 is equal to the log of 2 to the power of r. Now we haven't talked about what base these logs are to, but we could think of them We don't have to do this, but let's think of them as being the log to base 10. So we can now do 10 to the power of on both sides, right? So we're undoing the logs. What we've got left with is this: 1 plus r over 100 to the power of 72 is equal to 2 to the power of r. Now let's look, because we're getting incredibly close to what we need to show. We need to show that it fits this equation. So look, we're just about there. We just have to subtract that term from both sides. Okay, so 0 is equal to 2 to the r minus 1 plus r over 100 to the power of 72 as required. So there you go. That's quite a different exponential growth question from what we've seen in past years. I think it really tests your understanding, and it also tests your ability to read problems and understand what you're being asked to find. If you've got any questions on that one, please just leave me a comment on the video and I'll try to help some more. Thanks for watching.